Hello everybody, welcome back. Welcome to Unit 10. This is Lesson 2 titled Conjugate Acid-Base Pairs. So in the last video, we talked about intro to acids and bases, covered the two different theories, and existed in some similar characteristics between the two of them. But today we're going to cover the Bronsted-Lowry theory in a little bit more detail and how it relates to these conjugate acid-base pairs. And so one thing that, this definitely comes in handy when we're talking about this is the acronym BAD. So BAAD. And this kind of describes the Bronsted-Lowry acids and bases that we discussed a little bit before. And so what this says, it says that bases accept and acids donate. What are they accepting or donating? That's that H+. So H+, again, is your hydrogen ion. It is also called a proton. If you think about it, hydrogen has one proton, one neutron, one electron. I lied. Hydrogen just has one proton and one electron. When you lose an electron, you have that positive sign. So H plus is literally just a proton. So bases will accept or gain an H plus, and acids will donate that H plus. And so bad is something you need to remember. And so when we're talking about this, most compounds either does one or the other, but water can do both. So water can be a proton donor. Remember, proton is again that H plus, or it can be a proton acceptor, so we can gain that H plus. Depending on who that water molecule is with, it will do different things, and so we call it amphoteric, and it changes its behavior depending on who it's hanging out with. And so when we're doing a conjugate acid-base pair, a conjugate base is what remains when an acid gives up that H+, and a conjugate acid is what remains or what is formed when a base accepts that proton. And so if you're thinking about this, you should think of, learning a foreign language. If you're conjugating a verb, they all kind of look the same, though there are similar differences. But the conjugate acid-base pair, you want to look for something that, looks similar. So if we look at NH3, we want to find its partner on the opposite side of the reaction. And so we know that NH4 plus looks very similar to NH3 plus. So that's our pair because they look very close to each other. If we have, water, you want to find something on the opposite side of the reaction that looks like water. And there you have that. Again, the only differences between these two pairs is, in the green path, one gained or accepted a, proton or H+, and one of them lost it. And so that water, because again, we have BAAD, going from this to that, you lose or donate that H+, that makes H2O the acid, which makes NH3 the base, and then you have your conjugate acid-base pairs. So again, we're going to spend more time going over this, but this is kind of how you need to be thinking. Find something that matches up. So again, bases accept, acids donate. This is bad. Conjugate base is what remains after the acid gives up that H+, and conjugate acid is formed when that base accepts it. So again, this is kind of hard to kind of just picture. Let's jump into some questions. So generally, they'll give you an equation and ask, what is the conjugate acid-base pair? And so your first step should be, well, one, let's find the things that look similar. So here we have HClO4. We want to find something on the opposite side of the reaction that looks basically like that, but either has one less H or one more H. And so that pair is this. So in order to get from HClO4 to ClO4-, you have to donate or lose an H+ to go this way. Now, remember, if we think bad, bases accept, acids donate, if the HClO4 donated that H plus, that makes it an acid. And so once that acid actually loses that H plus, that makes this the conjugate base. So you have an acid and its conjugate base. So something that looks like it, but that base, remember, is one hydrogen less. Now, if you look at the other pair, again, here we have water. We know it's going to match up with this because, again, the only difference between those two things is one H. So in order to get from H2O to H3O plus, you had to gain or accept an H plus to go from H2O to H3O plus. Now, what that means, again, using bad, that makes water our base because it has the capability to accept the H, and when it actually does accept the H, that becomes the conjugate acid. So again, on one side of the equation, let me get a different color. On one side of the reaction, you'll have an acid and a base, and on the opposite side, you'll have a conjugate acid and a conjugate base. Acids will pair and has one more H than the other one. Your base will pair, and then its conjugate acid will have one more H. So again, it's all about just breaking it down and finding its pair and looking to see what happened to the H. So if we look at this one, again, we have this with this, we have this with that, and same reaction before. So we're going to kind of flip back and forth. Which compound will donate or lose an H? That's going to be this. Because again, if you find its matching pair, we're one H short. And so when it actually donates that proton or that H, it now looks like that. Now it's asking for, which will accept a proton. So again, if you're thinking bad, H2O has the capability of accepting that H, and when it does accept that H, it looks like H3O plus. And so with that, you have your acid is going to be HClO4, and your conjugate base, again, is that acid minus that H. And then your base is your H2O, and the conjugate acid, again, that something that looks similar but has one more H, is that H3O plus. So that's basically it. Let's do one more together. So again, your first step is you want to find the pairs. So what on the opposite side of the reaction looks like H2SO3? And hopefully you said HSO3 minus. So again, you're missing that one little H. So in order to go from this to that, we lost or donated H plus. So H2SO3, is like, hey, I'm going to give, one H away. So that makes that the acid, and this the conjugate base. Bases accept, acids donate. So because we went from this to that, and in order to go from this to this, you have to lose an H. That means this acid has the capability to actually donate an H, and when it does, that makes the conjugate base. So your next pair, again, is this. And in order to go from H2O to H3O plus, you need to gain or accept an H plus. And so if you have the capability to accept an H plus, that makes you a base. And when you actually accept the H plus, that is your conjugate acid. So those are your two pairs. You'll get an acid and its conjugate base, or you'll get a base and a conjugate acid. So that's how they get paired up together. So again, we have, just to do this quickly, this and this. We have this and that. And so this is your lose H plus, this is your gain going to say accept as well. Donate up here. So H2SO3 has the capability of donating, which makes it the acid. After it does do that donation, it looks like HSO4 minus, and that makes it the conjugate base. Then we have which one will accept a proton. That is H2O, our base. And then when it actually accepts an H plus, it is H3O plus, and that is our conjugate acid. So again, it's looking for that pair, and the only difference between the two things is 1H. And so that's pretty much it. We are going to practice more together, but on the next video, we will cover the pH scale and pH indicators. On that note, have a wonderful day.